I just want to do one really quick demo that we didn't get a chance to do in class. If you don't have something like the wood block to do this at home, you just need something that is moderately heavy and smooth on the bottom. So if I've got like a calculator, this is going to work. I just want to make sure I'm not using a calculator that has like little grips on the bottom. I want it to be something that's relatively smooth. It doesn't need to be slippery, just smooth. I've got a bottle of hand sanitizer here. This is going to work because there's no grips on the bottom. It's just smooth plastic. And then a sheet of paper. Could be a piece of notebook paper, typing paper, whatever. So we said Newton's first law says that an object at rest wants to stay at rest, and it will unless it's acted on by an unbalanced force. So if I've got my object on my paper, it's at rest and it'll stay at rest unless if I start to pull slowly on this, it starts to move. It doesn't stay at rest. That must mean there's an unbalanced force. And that is friction. When I try to pull the paper out, when I pull on the paper, if the bottle didn't move, it would just stay here and the paper would come out from underneath it. Well, friction doesn't want that to happen. Friction wants the bottle to stay on top of the paper. And so there winds up being some friction that pulls the bottle forward to keep it on the paper, and there's nothing to balance that out. So we've got an unbalanced force of friction causing our object at rest to start to move. But if I pull quickly on the paper, I can actually get it to come out from underneath the bottle. And it doesn't move very much. It might even look like it doesn't move at all. But it is moving a tiny bit. If you're having trouble getting that to work, so you got your object on your paper, if you pull over like the edge of the table or the desk and you just pull down on the paper, that can make it easier. Just make sure you don't accidentally fling anything breakable off the edge of the table. But if I just pull straight down on the paper, I can get it to come out from underneath the object. And what's going on there is we know that our object at rest wants to stay at rest. We call that property of matter inertia, that it doesn't want to change its velocity. And because it's at rest, it's going to stay at rest unless there's an unbalanced force. Well, normally, if I pulled really slow on the paper, there'd be this unbalanced force of friction continuously acting on the object, letting me drag it across the table. But if I pull really fast, the paper gets pulled out from underneath. It accelerates a lot faster than friction can actually pull the object forward. And so if I pull the paper hard enough, I can actually get it to slip out from underneath the calculator before friction is able to speed the calculator up enough to stay on the paper. And so it winds up looking sort of like a magic trick where it stays in place. It's actually moving a tiny bit, but it only gets a chance to move while the paper is still in contact with it. So if you've ever seen someone do like pulling a tablecloth out from underneath a bunch of dishes, that's how it works. We can do the same thing in reverse to see the some other applications of Newton's first law. So we know that an object at rest wants to remain at rest. And if I push slowly on it, I just pushed across the table, if I push the paper really hard and really fast, I can actually get it to slip underneath the object. This is probably the trickiest one. But I can actually get it to go underneath the object. This is the same way that you would pick up like a pizza from an oven with a big pizza peel. So if you've ever been to like Punch Pizza and you've seen them taking the pizzas out, they have this big blade, and if they go really fast, they can stick it under the object because when it's at rest, it wants to stay at rest, and it's going to stay at rest until some unbalanced forces act on it. While the paper or the pizza peel is sliding under it, there's a little bit of friction trying to push it forward, but if you push the pizza peel or the paper fast enough, friction just doesn't have enough time to speed this up, and you can actually get the paper to go underneath it. Now, once it's under, if I go slower, I can move this around. The same way you get the pizza off the peel is by using Newton's first law, but this time the part of it that says an object in motion will remain in motion. It'll have a constant velocity unless there's an unbalanced force. In this case, if I want to get this off, I can get this going pretty quick, and then if I just suddenly stop moving the paper, the pizza or the block or whatever's on here just keeps sliding on its own until eventually friction with the table is able to stop it. But in order for me to fling it off the paper, I'm not pushing it off the paper. It's just already in motion. When I stop moving the paper, it keeps moving. Again, we call that inertia. Objects want to have a constant velocity. If they're at rest, they want to stay at rest. If they're in motion, they want to stay in motion. And so we can see that an object at rest wants to stay at rest, and you have to continually and gradually apply a force in order to change it. If it's in motion, it'll stay in motion at a constant velocity, and you can even get the object to continue in motion when you're no longer pushing on it, because the object stays in motion on its own. It only stops because there's friction, but you don't need to be pushing it to make it move.